formula of a Fourier series, or the f of x equal to a0 plus summation of n equal to 1 to infinity a n cos n x pi or n pi x by l, summation of n equal to 1 to infinity b n sine of n pi x by l, where a0 is equal to 1 by 2l integral c to c plus 2l f of x into dx. A n is equal to 1 by l integral c to c plus 2l f of x into cos n pi x by l into dx. And bn, the difference of an and bn is only cos and sine. So you should remember these things. Few more things I explain about the basic concept of the trigonometric, if you remember, and the integration by parts. Now, without taking so much time, we'll move ahead, or we'll solve the first type of Fourier series. So that is type 1, you should remember. When limit point is 0 to 2 pi, when limit point is 0 to 2 pi or period is 2 pi, then what we have to apply here? Now you can just see that अब लिमिट पॉइंट आपके लिए यहाँ पे 0 to 2 pi है. So you should remember that we have to replace we have to replace the term 2l by 2 pi, और जहाँ पे भी l दिख रहा है वहां पे आपको pi रखना है. Let c is kept as it is, so my formula will becomes f of x equal to a0 plus summation of n equal to 1 to infinity a n cos of nx plus summation of n equal to 1 to infinity bn sine of nx. Now what I clearly stated that whenever the limit point is 0 to 2 pi, or limit point is 0 to 2 pi, you should write l equal to pi. Now you have to see this formula clearly here. You can just see that a n into cos nx pi. So while substituting l equal to pi, l के जगह पे आपको pi रखना है. कब? When the limit point is 0 to 2 pi. 0 to 2 pi. So we have to substitute here l equal to pi, so that our formula will becomes l equal to pi. Pi get cancelled, you will getting only cos nx. Similarly, l equal to pi. Pi get cancelled, you will getting sin nx. Now so 1 by 2 pi integral 0 to 2 pi. Why I'm saying 0 to 2 pi? Because the limit point is clearly given, that is 0 to 2 pi. So moving ahead with this part, my formula for a0, which is equal to 1 by 2 pi integral 0 to 2 pi f of x into dx. F of x into dx. And an is equal to 1 by pi integral 0 to 2 pi f of x into sine of nx into dx. Sorry, an है तो we have to write cos nx into cos of nx into dx. bn is equal to 1 by pi integral 0 to 2 pi f of x into sine of nx into dx. Now just see and observe this part a0, an, bn. For this part and this part, you'll clearly observe that is whenever the limit point will be 0 to 2 pi, what we have to substitute and what we have to perform here. We have to substitute L equal to pi clearly so that we will getting this formula. Now moving ahead with the first problem of Fourier series, when the limit point is 0 to 2 pi. The first problem, obtain Fourier series f of x in 0 to 2 pi, where f of x equal to x into or x 2 pi minus x, 0 is less than x is less than pi or less than or equal to, similarly pi is less than x or equal to less than x is less than or equal to 2 pi, or this is a strictly less than 2 pi. So this is our problem is given, that is we have to find or obtain this Fourier series to calculate or finding the Fourier series. Now the first observation must be the question's limit point. So the limit point is clearly given 0 to 2 pi. You can just observe this part. I'm writing this part, so you can just see that limit point is 0 to 2 pi. या फिर यहाँ पे दिया रहे नहीं दिया रहे. So it will be a same for both the part. But the function is divided into two parts. That is, the first function is x, and whose limit point is 0 to pi, and the second function is 2 pi minus x, whose limit point is pi to 2 pi. So what we have to do, what we have to perform here, we have to perform again here while substituting this part, or I'm just writing the solution of this part. So solution, first we have to write the formula of Fourier series f of x equal to a0 plus summation of an cos of nx y nx, because the limit point is 0 to 2 pi, plus summation of bn sine of nx. So this is my Fourier series. We can give this is equation number 1 if you want, or kept as it is, or we can say that is that we have to substitute the value in Fourier series equation. So this is basically a Fourier series equation. Now moving ahead with one by one, first we have to solve a0. So a0 is equal to, we aware about the formula 1 by 2 pi integral 0 to 2 pi f of x into dx. So we have to substitute here. So a0 is equal to 1 by 2 pi. Now here if you observe that 0 to 2 pi is divided into two parts. The first part is 0 to pi and the second part is pi to 2 pi. So we have to divide this function, that is 0 to pi. That time fx is what? X. So we have to write x into dx plus second part is pi to 2 pi, and that time the function is 2 pi minus x. So 2 pi minus x into dx. So we got the result of this part, or we substituted the value of the function only. Now we have to integrate this part only. So what we have to perform here, we have to perform here clearly, that is a0 is equal to 1 by 2 pi. So integration 1 by 1 we have to calculate. X integration will becomes x square by 2. Limit point as it is 0 to 2, sorry, 0 to pi, plus we can take the integration of the second part, 2 pi minus x. So 2 pi is a constant term. So whenever there is a constant of integrations, we can write dx is with respect to x is there. So we have to write as it is 2 pi x minus, and integration of x will becomes x square by 2, and limit point completed, pi to 2 pi. So this is we got after integration of the first part x into dx, then the second part 2 pi minus x. Now we have to simplify this part, that is a0 is equal to 1 by 2 pi, substituting upper minus lower. So you can just observe this part, while substituting the upper limit you will getting what? Pi square by 2, and lower limit is 0, so we can write, if you want you can write as it is 0. So upper limit minus lower limit we performing in the first integration parts, plus we have to perform here again upper limit minus lower limit. So while substituting 2 pi at the place of x, you will getting 4 pi as 4 pi square, and substituting here you will getting what? 4 pi square, but this 2 will get cancelled, 2 ones are 2, 2 twos are 4. So this will becomes 2 pi square. So 4 pi square minus 2 pi square, you will getting what? Only 2 pi square. Upper limit you will getting, lower limit का minus sign रखो. Now we have to substitute pi here, so 2 pi into pi, this will becomes 2 pi square. While substituting here, it will becomes what? Pi square by 2. So I'm writing here 2 pi square minus pi square by 2. So this is my upper minus lower limit in both the parts. Now, if we expand this bracket, then this pi square and this pi square is not going to cancel because of this minus sign. Minus minus this will becomes plus, and pi square plus pi square, which is equal to pi square. Sorry, pi square by 2 plus pi square by 2, which is equal to pi square. And here, if you will observe 2 pi square, and by using this minus sign, you can see that 2 pi square minus 2 pi square, which is going to cancel with each other. So I'm writing here, after expansion of this parts, a0 is equal to 1 by 2 pi into pi square only. Now this pi is cancelled with this square, and at the end you will getting a0 is equal to pi by 2. a0 is equal to pi by 2. Now moving with the an part, we have to calculate the an part. Or I'm writing this is an equation number, if you just representing, this is equation number a. Sorry. Now we are moving ahead with the next part, that is we have to calculate the an part. So an is equal to, as we aware the formula, 1 by pi integral 0 to pi 2 pi f of x into cos of nx into dx. So we have to simplify here. An is equal to 1 by pi as it is. Now the 0 to 2 pi is divided into two functions. The first one is x. So integral 0 to pi fx, the first is x into cos of nx into dx plus integral pi to 2 pi 2 pi minus x into cos of nx into dx. So we have to perform, because why we are performing these two parts, because it is clearly mentioned that the function is divided into two parts. So we have to integrate this part by using integration by parts. And so you can just observe this part as I mentioned, that is, this is my u part and this part is my v part. Similarly here it is u part and this is v part. So we have to perform integration by parts here. So an is equal to 1 by pi 1 by 1 separately. So u as it is, x as it is, we have to take the integration of cos nx. Integration of cos is plus, so sine of nx, and divide by, we have to divide the terms of x variable. So n we have to divide here n. Then minus, take the derivative of x. So derivative of x will becomes 1 and integration of sine will becomes minus cos. So we have to write here minus cos of nx upon, already n is there, so we again n will divide it, so it will becomes n square. So this is first part. Integration by parts is completed because next derivative is not possible, so that we can write as it is 0 to pi. So this is first integration by parts, plus we have to take the second integration by parts here. You can observe that this is u, so u part kept as it is 2 pi minus x as it is. Take the integration of cos nx, so it will become sine of nx upon n, minus, take the derivative of this part with respect to x. So derivative of 2 pi will be 0 and derivative of x will be minus 1. So we have to write as it is minus 1, and integration of sine nx by n will becomes minus cos of nx upon n square. Why n square? Because already n is there. So this is our second integration by parts is also completed. Limit point is pi to 2 pi, and this curly bracket is also completed. So what we applied here, that is integration by parts. As I mentioned in a first lecture, or like yesterday, whenever we have to use Fourier series, or whenever we have to tackle the Fourier series, and if algebraic functions and trigonometric functions are present, or if algebraic functions or exponential functions are present, we have to use by hook or crook integration by parts concept. Other, no concept or no integration rules can occupy or can use for solving such a kind of numericals. So you should remember the formula of integration by parts. We have to kept as it is, taking the integration of v parts. So integration of cos nx is sin nx upon n, because we have to take the whatever the terms is given, that is nx. So variable of x having n, So we have to divide by n. Then minus sign, as I mentioned in a formula, taking the derivative of x is 1, or x first derivative you have to take, so it will becomes 1. Further again taking the integration of sine nx. So sine nx integration is minus cos nx by n. Already n is in the denominator, so it will becomes n squared. Later why we not applied next derivative or next terms, because there is the absence of u variable. So u is here 1. So if I'm going to differentiate 1 with respect to x, I will get 0. So therefore we have to stop here as it is. Similarly, we perform u kept as it is. Integration of cos nx is sin nx by n, minus taking the derivative of u, that is 2 pi minus x. So we will getting minus 1 into minus cos nx by n square. Now we have to perform the upper limit minus lower limit here. So an is equal to 1 by pi, substituting upper limit. So if you remember, I don't know whether you people are remembering or not this kind of a concept, because as I mentioned, that is, whenever we have to tackle the Fourier series problem, you should remember this kind of a concept very well. Which concept? Sine 2 pi n is 0 and cos 2 pi n is 1. Sine n pi is 0, cos n pi is plus minus 1. So you hope you should remember this formula or this value, standard value, so that it will helpful for solving this kind of a numerical. So substituting upper minus lower limit here. So substituting here first. So at by we have to put at the value of x at is equal to pi. So pi into sine n pi. Pi into sine n pi. Whether sine n pi is equal to what? As in above mentioned clearly, sine n pi आपका 0 होता है. So this whole part will treated as a 0. We have to kept as it is 0. Now lower upper limit we have to put one by one first. So putting the upper limit, so x pi into sine and pi. If you want, I can show you the one step here. Sine of n pi upon n, and minus minus it will become a plus. We have to put here the upper limit as it is. So plus cos of n pi upon n square. So this is my upper limit. We have to apply the lower limit as it is 0. So 0 into anything will become 0. Minus minus plus, and cos 0 is equal to 1 hota hai. You can just put in a calci and you can observe that cos 0 is equal to 1. So minus minus plus, so 1 by n square you will get in. So this is first part, upper limit minus lower limit, plus will moving the second part, substituting here. So you can just observe that while putting x equal to 2 pi, so 2 pi minus 2 pi will become 0, minus minus minus. So we have to put minus as it is. Substituting x equal to 2 pi, so you will getting cos of 2 pi n upon n square. Upper limit we have to put, that is lower limit, as a minus sign, substituting pi. So 2 pi minus pi, it will becomes pi. 2 pi minus pi, it will becomes pi into sine of n pi upon n. Putting here to minus minus minus, so it will becomes minus pi. So it will becomes cos of n pi upon n square. So this is bracket also completed, this square bracket completed, and this curly bracket is also completed here. So substituting upper limit minus lower limit point, as I mentioned, cos n pi is plus minus 1, sin n pi is 0, cos 2 pi n is equal to 1, sin 2 pi n is again 0. But while you can observe this part clearly, pi sin n pi, this is plus, this is minus. So these two parts again get cancelled. I'm writing this part here easily. Now cos n pi plus here, cos n pi plus here, you can just see that this is minus minus plus. So we have to add the terms first. So 1 by pi a n is equal to 1 by pi 2 cos n pi upon n square. Now cos 2 pi n is equal to what? Plus 1. Now you can just observe that this is minus 1 by square. Cos 2 pi n आपका क्या होता है? That is plus 1. So plus 1, or I'm writing here for better understanding, cos of 2 pi n is equal to 1. So this is equal to 1. So minus 1 by n square and minus 1 by n square, it will becomes minus 2 by n square. So this is, we got the terms 2 cos n pi by n square minus 2 by n square. Now what we have to perform here, 2 we can get outside, or common factor we can take outside, constant term is there. So a n is equal to 2 by pi. The cos of n pi minus 1 upon n square. So 2 by pi into cos n pi minus 1 upon n square we got. But here, as we remember, or as we should aware, cos n pi is equal to plus minus 1, or we can write as a minus 1 raised to n. So we have to put both the value here. So I'm writing here the statement clearly. In cos of n pi, if n is even, if n is even, then it is 1. But if n is odd, but n is odd, if n is odd, then it is minus 1. So we will getting what? A n is equal to 2 by pi cos of n pi minus 1 upon n square equal to, it will getting two values here. Why two values? You can just observe while putting plus 1 here. जैसे ही हम plus 1 रखेंगे, so you will getting 0, because putting 1 here cos n pi, जैसे ही n even रखोगे तो you will getting cos n pi is plus 1. So 1 minus 1 will become 0. When 0, that is when n is even. When n is even. And when we are putting minus 1 here, so minus 1 it will becomes minus 2. So you will getting a n is equal to minus 4 upon pi n square. That's why I written clearly in cos n pi only, not n. नहीं तो गलती से यहाँ पे भी आप +1 - 1 रख के ऑब्जर्व करना चालू कर दोगे. So only in cos n pi, when n is even, you will getting the value of cos n pi is +1, and in cos n pi when the value of n is odd, then you will getting cos n pi is equal to -1. So while putting both the value, you can just observe this part. When n is even, you will getting 0, and when n is odd, n is odd. तो ये स्टेटमेंट आप लिखना है लिखो, नहीं लिखना है मत लिखो, बट ये चीज हमको करके दिखाना रहता है. So when n is even, it will become 0 n, and when n is odd, you will getting -4 by pi n square. तो n का वैल्यू हमको क्या मिल रहा है? 0 and -4 pi n square. 4 upon pi into n square, we getting the value of an. Now bn we have to calculate. So I'm writing here that is an is equal to -4 upon pi n square. This is equation number. Now moving with the next part, bn is equal to, again the same formula, 1 by pi integral 0 to 2 pi f of x into sine of nx into dx. So bn is equal to 1 by pi integral 0 to pi x into sine of nx into dx plus integral pi to 2 pi 2 pi minus x into sine of nx into dx. Again, we have to apply the integration by parts here. So bn is equal to 1 by pi again we have to give the same name here, that is u and v. U and v. So you can just see that u into v, x as it is, integration of sine will becomes minus cos of n pi x, sorry, nx nx upon n. When taking minus sign as it is, derivative of x will becomes 1, integration of cos will become sine, लेकिन minus है तो we have to write as it is minus sine of nx by n square, limit point 0 to pi, plus we have to take the integration of this part again. So 2 pi minus x into integration of sine is again minus cos nx by n, minus integration of this part is 2 pi 0, and this is -1, and integration of cos will becomes minus sine of nx upon n square, limit points pi to 2 pi to 2 pi. Now we have to put the upper limit minus lower limit here. So while putting the upper limit minus lower limit, you will getting bn is equal to bn is equal to 1 by pi Substituting upper limit, so 2 pi minus, substituting here, minus 2 pi cos 2 pi n upon n. This is 0, so we have to put as it is plus 0. The upper limit is kept as it is. This part minus, taking the lower limit, so 0 into anything 0, 0 sine 0 is by default 0. The lower limit is by default 0. Plus, substituting the upper limit, so 2 pi minus pi, 2 pi minus 2 pi is 0. So this part is 0 into anything 0, sine 0 is 0. So the upper limit is 0 minus lower limit, substituting 2 pi minus pi, 2 pi minus pi. So it will becomes pi, but this is minus, so minus pi into cos of n pi upon n. Substituting lower limit here, so you can just observe this part, sine n pi is 0. So this whole part is 0, so we can write as it is. So this is upper limit minus lower limit we applied. Now cos 2 pi n is 1. Cos 2 pi n is equal to 1. So we can simplify this part. Bn is equal to 1 by pi. We have to simplify the, so minus cos 2 pi n is 1. So minus 2 pi upon n. This is 0, 0. This is minus, minus, plus. So plus pi into cos of n pi upon n. So we can take pi as a common factor and we can get cancel pi pi. So at the end we'll getting Bn is equal to 1 by pi. Now n is denominator same, so I'm taking writing this part. Sorry. Now you can just see this part. 1 by pi, taking pi as a common factor, pi get cancelled. So the remaining will becomes what? N as it is. So cos n pi minus 2 upon n will get it. Now again we have to simplify here. So you will getting two values again. Here we will getting two values. एक मिस्टेक हुआ है हमसे यहाँ पे, लेकिन किसी ने ऑब्जर्व नहीं किया. While putting upper limit here, it will becomes only pi. So this is not 2 pi. So this is again minus pi. And at the end, if you observe this part, तो pi pi get cancel तो हो गया हमारा यहाँ से. You will getting pi pi get cancelled, so you will getting only cos n pi minus 1 by n. पाई सब्स्टिट्यूट करेंगे तो पाई इंटू आएगा, 2 पाई नहीं आएगा, वो हमने मिस्टेक किया था. और यहाँ पे भी आपको मिलना चाहिए था, सॉरी. दिस इज 2 पाई एन नहीं, पाई एन. दिस इज cos of pi n only. Pi n. So this is again So we're getting Bn is equal to 1 by pi. This will becomes minus pi into cos of n pi upon n. Now you will getting here Bn is equal to plus cos pi of cos of n pi upon n. And at then Bn is equal to you will getting 0. Why? Because minus pi cos n pi by n and plus pi cos n pi by n, both the part will get cancelled and they will getting the bracket term as a 0. So 0 into anything will become 0. So this is equation number C. At last, what we have to apply? We have to put equation A, B, and C in the Fourier equation. What is our Fourier equations or Fourier series equation? As all of you must remember this equation, that is f of x equal to a0 plus summation of an cos nx plus bn sin nx. तो इसमें हम लोग सब्स्टिट्यूट यहाँ पे करेंगे तो हमको इक्वेशन मिलेगा. तो इक्वेशन A, B, and C in Fourier series. So therefore f of x equal to a0 is how much? Is a0 was pi by 2, if you remember. A0 was pi by 2, so we have to write directly here. I'm writing this part is directly a0 is equal to pi by 2. So pi by 2. Now bn तो जीरो है तो वो तो जीरो हो जाएगा पूरा पार्ट. सिर्फ अभी an का वैल्यू हमको देखना है. -4 pi by n square. So plus summation of an is -4 pi n square into cos of nx. अब यहाँ से आप फाइनल रिजल्ट आपको मिल जाता है f of x इक्वल टू pi by 2 -4 pi into summation of n equal to 1 to infinity cos nx upon n square. और ये हमारा फाइनल रिजल्ट हमको मिल जाता है. Now just see to it that this example, I'm just taking the attendance. Now, if anyone having any doubts in any step, so you can ask. I will explain again. If no doubt, we can stop here. Very lengthy questions are there on the basis of Fourier series. So you at least you have to integrate and you have to solve. Whether the question was in MCQ format or whether in a descriptive format, you must have to attain or you must have to solve the questions. So you should prepare according to that. This is a इसके बाद एक और चैप्टर है कॉम्प्लेक्स वेरिएबल. उसमें भी थोड़ा डेरिवेटिव वगैरह ज़्यादा है. This two chapter is a heavy chapters. So anyone having any doubts regarding this problem, so please ask. If no doubts, so we can stop here and we'll meet on Friday. There will be a internal, sorry, tutorial. So there will be a tutorial on Laplace transform and inverse of Laplace transform. There will be a six question or seven question I will give, you have to attempt any four. Each question will carry 5 marks, so 5 fours are 20. Sorry, each question will carry 5 marks. You have to attempt any four questions, so 4 into 5, that is equal to 20 marks, and 5 marks is considering for your attendance. So there will be a 25 marks for term work. So you should consider this tutorial as an important. Don't consider कि ये बस ऐसे ही हमको दे देना है. So I'm considering there will be a no doubt because किसी ने कुछ पूछा ही नहीं. So we can stop here.
Yes, sir.
Okay. Thank
हाँ
you.
सर।
ठीक है, चलो, थैंक यू, बाय बाय, टेक केयर.